I am Ennemcien. We have to discuss some physical aspects behind vibration. We have seen the spring load system in vibration. Actually, vibration is a tug of war between two elements. One, inertia factor of the vibrating system. Two, restoring force from another agent. In spring load system, the inertia factor is the mass of the load, and the restoring force is provided by the stiffness of the spring. How does it happen? A spring load system, for example, will not vibrate by its own will. An external agent is required to start the vibration. As the agent passes the system, he becomes naughty. He pulls down the load a little and leaves the place. What else he can do? Now the load begins its journey downward. The spring pulls it upward. Now these two factors come into fight. Let us see how does it happen. This is the equilibrium position or resting position or mean position. The vibrating system, load in the case of spring load system, that system is load. Vibrating system is the load. The load is displaced initially by an external agent. As it moves to the right, the restoring force is developed within the system, within the spring system, and it pulls the load back. This restoring force is proportional to displacement from this equilibrium position. As x increases, the restoring force also increases. Ultimately, at the right extreme, the vibrating system gives in to the restoring force. It stops there and comes back as a good boy. Now the spring is getting relaxed. If the system comes back and remains at rest at O, the spring is totally relaxed and the restoring force will vanish. But as the load approaches O, its speed is increasing and it becomes a maximum at O. Because of inertia possessed by the vibrating system, it is unable to stop there. Just like a 100-meter, an athlete taking part in a 100-meter race, as he approaches the finishing point, he can't stop by himself. He continues his running a little more. Like this, that is due to inertia. Like this, the load, when it comes to O, it has maximum velocity. So it can't stop by itself because of inertia. So it passes to the other side of O. This time it compresses the spring. Again, the spring is deformed. Restoring force develops. And it again pushes the load towards O. Because of the kinetic energy possessed by the load, it continues its motion, and finally at the left extreme, it gives in to the restoring force because the restoring force becomes maximum at this point, and it retraces its path. Again, when it reaches O, its kinetic energy is maximum or velocity is maximum, and because of inertia, it continues its forward motion. This is repeated, and this is reason how vibration takes place. Now, another point. Suppose the load is when the load moves from A to O, spring is also pulling the load towards O. This doesn't mean that the restoring force is in the same direction of x displacement because x is always measured from O. When the load is moving from A to O and it comes at this point, its x value is this, but force is in this direction. So, whatever be the direction of motion of the load, the restoring force is opposite to the displacement. Okay, thank you.